Welcome to Nobody's Fuel. The purpose of Nobody's Fuel is to use the facts of science to cut through the fog of misinformation which seems to surround many discussions of energy, the environment, and climate change. The more energy people use, the wealthier they are in all the many aspects of the word wealth. They are better able to raise others out of poverty, to protect the environment, and to adapt to climate change regardless of what is causing it. Today, fossil fuels are 85% of our energy supply, and the burning of them is raising the level of carbon dioxide in the atmosphere and contributing to global warming. Fossil fuels are so important to us that we cannot just turn off the tap and hurt people. People are as much a part of the world's environment as any other living thing. Nobody's Fuel shows that only nuclear fission energy using fast breeder reactors can replace fossil fuels on the scale required and can power the world for tens of thousands of years.
This section discusses where fossil fuels come from. What are they? How much we use? How we use them? And finally, how important energy is to us. Nuclear fusion that powers the sun is the ultimate source of fossil fuels. Nuclear fusion refers to combining atoms to generate heat, whereas the nuclear energy we use today to generate electricity comes from nuclear fission, splitting atoms to generate heat. Some radiation from the sun is in the form of heat which warms parts of the earth, causing winds. Other radiation energy evaporates water that rains or snows at higher elevations and provides hydropower. Visible light drives photosynthesis for growing plants, which are the source of all food on Earth. Only 0.1 to 0.5% of sunlight falling on plants is converted to plant material. Hydro, wind, solar, and biomass represent the renewable energies, those available in real time, season after season. It required millions of years of ancient sunlight to accumulate plant and animal material. This was buried and transformed into coal, oil, and natural gas. These are the non-renewable fossil fuels and are really concentrated solar energy stored in the Earth's crust. Fossil fuels are chemical compounds of carbon and hydrogen called hydrocarbons. The proportion of carbon to hydrogen determines the characteristics of the various compounds. For example, as the hydrogen content increases, the compounds become lighter. They change from a solid, such as coal and tar, into a liquid, such as oil. Finally, with enough hydrogen, they turn into a gas, such as natural gas and propane. Coal is a solid containing much energy by volume. Coal was first used in China as early as 3,000 years ago to smelt copper. Coal is retrieved from the ground by coal miners in caverns deep underground or closer to the surface by strip mining, where huge steam shovels strip away the top layer of earth and then layer after layer of coal. Next are the liquid fuels that power our transportation systems: gasoline, diesel, and jet fuel. Oil was formed not from plants, but when millions of tiny sea creatures, known as diatoms, died and piled up on the ocean floor. Earth's tectonic plates have shifted and folded over millions of years, resulting in pockets of oil distributed worldwide. Liquid petroleum is a mixture of complex hydrocarbon molecules. In the past, when petroleum sank deep enough in the earth, the excessive heat and pressure broke these molecules into shorter hydrocarbons, making natural gas, mostly methane, the chemically simplest fossil fuel. Natural gas is used to generate electricity and is piped to our homes for heating and cooking. Propane can easily be liquefied for storage in containers for home heating, or small applications such as barbecues, where portability is important. Finally, hydrogen is a valuable chemical, and this is by far the major use. Very little is used for its energy content, except for specific applications such as spacecraft propulsion. Most hydrogen is manufactured from fossil fuels, especially natural gas. In an effort to reduce carbon emissions, a certain amount of coal for generating electricity has been replaced with natural gas because, for the very same energy input, natural gas has 60% of the carbon emissions of coal, and oil has 70%. Coal contains 76,635 million joules per cubic meter. Next, gasoline is a liquid with a high energy density per unit of volume. Natural gas and hydrogen have a very low energy density per unit of volume. Coal is used as fuel for generating electricity and making coke for steel furnaces, etc. Oil is refined to make liquid fuels, such as gasoline and diesel, used to power the transportation sector. The energy concentration of liquid fuels allows the relatively small tank in your car to provide a range of hundreds of kilometers. Liquid hydrocarbons are easy to pump, distribute, control, and they vaporize readily for use in engines. Oil also has industrial uses and can be made into various products, such as nearly all forms of plastic bottles, bags, toys, electronics, etc., or even clothing such as polyester. Natural gas is used primarily for electricity generation and heating. More than 90% of hydrogen gas is used as a chemical and reacted during various chemical manufacturing processes. Finally, tar and asphalt are used for roads. Tar, or bitumen, in the Alberta tar sands of Canada, is reacted with hydrogen to make a synthetic crude oil. We've heard a little bit about fossil fuels being a primary form of energy. What is primary energy, and is there a secondary energy?
Primary energy is energy as it naturally occurs, such as coal, oil, natural gas, sunlight, and wind. We cannot use these forms of energy directly, so they are converted to secondary energy, the energy we actually use. It is the gasoline which actually moves our car, and the electricity which actually runs our vacuum cleaner. The fossil fuels, coal, oil, and natural gas, are the most important forms of primary energy today, simply because they are concentrated solar energy, which has been stored up over millions of years. Gasoline, refined from petroleum, allows us to harness concentrated sunlight to run heavy equipment and power our cars. Gasoline is very concentrated energy. For example, 1 gallon of gasoline was once roughly 100 tons of vegetation, or 40 acres of wheat.
Where do renewable energies fit into the picture?
Reserves of fossil fuels can be thought of like a giant bank account from which funds are withdrawn on which to live. Unfortunately, the funds are being used up and not being replenished. Renewable energy comes from the sun and is so dilute that it takes a lot of time to accumulate significant amounts. That's why it took millions of years to accumulate our fossil fuel bank account in the first place. Renewable energies are like having a small daily income. It's a bit like living paycheck to paycheck, except that sometimes the paycheck does not come through. For example, wind and solar deliver energy mostly as electricity, intermittently and often depending on the weather. The electricity must be used as it comes in, or it is lost. Hydro is better because water can be stored and used to make electricity as required, and for short periods can be used faster than water is being replenished. Biomass is a form of stored energy, usually in solid form. Much of it grows and is eaten or decayed over the course of one season. However, biomass in the form of trees can be stored for many seasons until harvested. For centuries, wood was the world's fuel of choice. Today, in developed countries, wood is rarely used directly for fuel because there's not nearly enough of it, and it is not as concentrated and easy to transport as fossil fuels. Liquid fuels, such as methanol and ethanol, can be manufactured from solid biomass, such as wood and grains, thereby making transport easier and biomass useful in a much wider range of energy applications. But these processes don't help because they are energy intensive. For example, growing corn and manufacturing it into ethanol requires a very large contribution of energy from our fossil fuel bank account. Almost the same amount of energy as in the ethanol itself.
This bar graph represents world energy consumption in 1970. Please take note that renewable energy comprises a tiny portion of this energy mix, with 93% supplied by fossil fuels. The unit of energy used throughout this presentation is the exajoule, or the abbreviation EJ, which is equal to the number 10 followed by 18 zeros. 1 exajoule is the amount of energy in the petroleum contained in 105 supertankers the size of the Exxon Valdez, or approximately 28 billion liters of gasoline, which is enough to fill the tanks of 500 million cars. By 1995, world energy consumption had grown substantially from that of 1970. As nuclear energy and hydro consumption grew between 1970 and 1995, the percentage of fossil fuels, that is, coal, oil, and natural gas, dropped by about 8 percentage points, from 93% to 85%, and has remained at 85% since then. The drop in fossil fuels occurred because nuclear energy grew from close to zero to about 7% of total world energy. Renewable energies are 8 to 9% of world energy. World energy consumption has grown from 227 exajoules in 1970 to an estimated 457 exajoules in 2005, an increase of 100% in 35 years. The point is that fossil fuels are 85% of world energy supply, and only fossil fuels can supply today's world energy requirements. Any alternatives to fossil fuels have to replace most of the 388 exajoules of fossil fuels to effectively control carbon emissions. This energy replacement target will rise as world energy demand rises. The term renewable energies usually covers hydro, biomass, wind, geothermal, and solar. By renewable, we mean inexhaustible. Renewable energies enter the world energy system as electricity, and their contributions can only be compared through the quantities of electricity produced. In this slide, the heights of the column under renewable energies are proportional to the amount of electricity produced from each renewable source. Is it possible to increase the 9% contribution of renewable energies to replace 388 exajoules of fossil fuels? Let's look at the history of renewable energies as fuel. Fuel supply in the United States up to 1850 was virtually 100% wood. In England, by 1700, trees for fuel had become scarce and people turned to coal. But the coal mines were flooding, and there was no good way to pump out the water. Some mines had to be abandoned. In 1712, Thomas Newcomen invented the steam engine specifically to pump water out of coal mines. Up to then, small amounts of power had been supplied by windmills and water power, but these were limited by wind currents and proximity to rivers. Coal and Newcomen's engine provided portable energy for the first time.